Hello there, and welcome to the Curious Mind Sleep channel. Tonight, we're exploring something extraordinary, your brain, and how it's controlling everything right now without you even knowing it. Take a breath. You didn't have to think about it. Your brainstem calculated oxygen levels, CO2 concentration, your body position, and orchestrated that breath automatically. While you lie here worrying about tomorrow, your brain is sending 120,000 signals per second to keep your heart beating. And that's just the beginning. Tonight, we'll explore 7 control systems your brain is running right now. Systems you've never had to think about. Systems that have been protecting you every moment of your life. Systems that will continue working all night long while you sleep. You don't have to control any of this. In fact, you can't. Your brain has been doing this job for millions of years of evolution, and it's far better at it than your conscious mind could ever be. So tonight, you have permission to lie here, learn, and let go. Your brain has everything under control. It always has. Maybe you came to this video because sleep won't come easily. Maybe your mind is racing through tomorrow's tasks, replaying today's conversations, worrying about things you can't control. That's okay. That's normal. That's human. But here's something remarkable. While your conscious mind races, your deeper brain, the parts you're not even aware of, is managing thousands of processes with perfect precision. Your autonomic nervous system, your temperature regulation, your cellular repair, your memory consolidation, your emotional processing, your circadian clock, your consciousness transition system. 7 major control systems, all working right now, all working together, all working for you. Tonight, we're going on a gentle journey through these systems. Not to teach you how to control them. You can't and you shouldn't try. But to help you appreciate what's already happening, to build trust in your brain's competence, to give you permission to stop trying so hard. Because here's the truth. Your brain knows how to sleep. It's been putting humans to sleep for 300,000 years. Your conscious worry doesn't help this process. It interferes with it. So our goal tonight is simple: to satisfy your curiosity enough that your conscious mind can relax and allow your deeper brain to do what it does best. If you fall asleep during this video, that's perfect. That means it's working. If you stay awake for the whole thing, that's perfect too. Either way, you'll learn something profound about the 3 pounds of matter inside your skull that makes you, you. Let's begin with the first system. The one that's working right now, this very second, to keep you alive without any conscious thought whatsoever. The autonomic control system. Let's start with something so essential that if your brain stopped doing it for even 3 minutes, you would die. And yet, you've never once had to think about it. Your heartbeat. Right now, your heart is beating, maybe 60 times per minute, maybe 70. It depends on your current state. Lying down, relaxed, perhaps slightly anxious. Your brain knows. It's monitoring everything. Your medulla oblongata, a small region at the base of your brainstem, about the size of your thumb, it's sending 120,000 electrical signals per second to your heart. 120,000, every single second. These signals adjust your heart rate based on oxygen demand, blood pressure, body position, stress level, digestion, temperature, and dozens of other factors you're not even aware of. You have never had to send a single one of those signals consciously. Not once in your entire life. Your brain has been doing this job since before you were born. Your heart started beating at 21 days after conception, orchestrated by your developing brainstem. And it hasn't stopped since. This is the kind of control that actually matters, not the anxious, conscious control that keeps you awake at night. Not the mental effort that exhausts you, but the deep biological control that sustains you. Your conscious mind tries to control everything and fails. Your brainstem controls what matters and never fails. The medulla oblongata, it sounds like a spell from a fantasy novel, but it's real. It's in your head right now, about an inch above where your skull meets your spine. And it's one of the oldest parts of your brain, evolutionarily speaking. Reptiles have a medulla. Birds have a medulla. Every mammal that's ever existed has had a medulla. This thumb-sized structure controls your heart rate, your blood pressure, your breathing rhythm, your swallowing reflex, and your vomiting reflex. All the involuntary actions that keep you alive. When you sleep, your medulla doesn't sleep. It never sleeps. While your cortex, the thinking part of your brain, shuts down for maintenance, your medulla keeps working. Heart, breath, heart, breath, all night, every night, for your entire life. Scientists at Stanford's Woodside Neurosciences Institute mapped the medulla in 2023 using advanced imaging. They found it contains over 75,000 neurons dedicated just to cardiovascular control. That's 75,000 tiny cells, each one connected to dozens of others, forming a network of breathtaking complexity, all to make sure your heart beats correctly. You don't have to know how any of this works. You don't have to understand the neurochemistry or the electrical pathways. The medulla understands. And it's been understanding since you were 3 weeks old in the womb. Let's talk about breathing. Take another breath. Notice how you didn't have to remind yourself? How your body just knew it was time? That's the pons, another region of your brainstem, sitting just above the medulla. The pons contains your respiratory control center, a group of neurons that set your breathing rhythm. Inhale, pause, exhale, pause, inhale. They've been conducting this rhythm since you were born. An adult breathes about 12 to 20 times per minute at rest. That's 17,000 to 28,000 breaths per day. Every one of those breaths requires precise coordination. Your diaphragm contracts, your intercostal muscles expand your rib cage, your vocal cords open, air flows in, your lungs extract oxygen, remove carbon dioxide, and the whole process reverses. Your pons is monitoring all of this in real time. It's checking the CO2 levels in your blood every few seconds. Too much CO2? Breathe faster. Enough oxygen? Slow down. Are you lying down? Adjust the depth. Are you anxious? Compensate with deeper breaths. You might think, but I can control my breathing. I can hold my breath. Yes, you can. For maybe a minute, 2 minutes if you're trained, but then your autonomic nervous system overrides you. It has to. Because your conscious mind is not reliable. It gets distracted. It falls asleep. Your brainstem never gets distracted. It's been breathing for you for every single moment of your existence, including right now while you listen to these words. This is the kind of control that actually matters, not the anxious, conscious control that keeps you awake, but the deep, biological control that keeps you alive. There's a nerve in your body that deserves special attention. It's called the vagus nerve. Vagus means wandering in Latin, and this nerve truly wanders. It's the longest cranial nerve in your body. The vagus nerve starts in your medulla oblongata and travels down through your neck, past your heart and lungs, all the way to your digestive system. It's your brain's direct communication line to all your major organs. About 80% of the signals traveling along the vagus nerve go from your organs to your brain. Yes, you read that correctly. Your brain doesn't just tell your body what to do. Your body is constantly updating your brain. Your stomach tells your brain about digestion. Your heart tells your brain about every beat. Your lungs report on every breath. This is why when you lie in bed anxious, you might feel tension in your stomach, tightness in your chest, shallow breathing. Your vagus nerve is sending distress signals up to your brain. But the beautiful thing is, this communication goes both ways. When you finally relax, when your parasympathetic nervous system activates, that's the rest and digest mode, your vagus nerve sends calming signals down from your brain to your body. Heart rate slows, digestion improves, breathing deepens. Your whole system downshifts into recovery mode. This nerve has been maintaining this two-way communication for your entire life. Right now, signals are flowing up and down your vagus nerve. Your brain is listening to your body. Your body is listening to your brain. Neither one is in charge. They're in partnership, and they're very good at their job. Your autonomic nervous system has two modes: sympathetic, the fight or flight response, and parasympathetic, the rest and digest response. Right now, as you lie here preparing for sleep, your brain is trying to shift you into parasympathetic mode. This isn't a switch you can consciously flip. You can't just decide, okay, parasympathetic nervous system, activate now. It doesn't work that way. Your brainstem makes this decision based on hundreds of signals: light levels, time of day, body position, safety, digestion, temperature, all monitored simultaneously. When parasympathetic mode activates, everything changes. Your heart rate drops by 10 to 20 beats per minute. Your blood pressure decreases. Your pupils constrict. Saliva production increases. Your bronchial tubes narrow slightly. Blood flow shifts from your muscles to your digestive organs. Your bladder relaxes. These aren't random changes. They're a coordinated shift orchestrated by your brainstem and your vagus nerve. It's your brain's way of saying, the danger has passed. The day is done. It's safe to rest now. Let's repair and restore. Every mammal has this system. When a lion finishes eating and lies in the shade, her parasympathetic system activates. When a dolphin sleeps with half its brain at a time, the resting half activates parasympathetic mode. When you finally drift off tonight, your parasympathetic system will take over completely. You don't have to make this happen. You can't force it, but you can allow it by lying still, by removing stimulation, by trusting that your brain knows when it's time. And it does know. It always has. So let's bring this back to tonight, to you, to this moment. Right now, your brainstem is working. The medulla is sending those 120,000 signals per second to your heart. The pons is orchestrating every breath. The vagus nerve is transmitting information in both directions. Your autonomic nervous system is trying to shift into parasympathetic mode. None of this requires your attention. In fact, paying attention to it might actually interfere. Have you ever noticed that when you focus on your breathing, it starts to feel manual, forced? That's your conscious mind trying to take over a job your brainstem does better automatically. The gift you can give yourself tonight is this: trust your brainstem. It has been doing this job flawlessly for your entire life. It kept you alive when you were a baby and had no conscious thought at all. It keeps you alive when you're asleep and your conscious mind is offline. It will keep you alive tonight, whether you monitor it or not. Your job is not to control these systems. Your job is to get out of the way. If you're feeling sleepy, wonderful. That's your parasympathetic system activating. Don't fight it. Don't try to stay awake to hear more facts. Your brainstem doesn't need your conscious awareness to do its work. It's been working in the dark, without applause, without recognition, since before you had memories. The autonomic control system is just the first of 7, but already you can see the pattern. Your brain is far more competent than you consciously realize, and that competence continues, whether you're awake or asleep. Let that be a comfort. Let that be permission to rest. Your brainstem isn't the only part of your brain working to help you sleep. There's another region, deeper in your brain, that's orchestrating something essential for sleep onset. Your hypothalamus. And it's conducting a precise thermal symphony right now. Sleep is impossible without the right temperature. Not the temperature of your room, though that matters, but the temperature inside your body, your core temperature. Right now, your core body temperature is about 37 degrees Celsius, 98.6 degrees Fahrenheit. But for you to fall asleep tonight, that temperature needs to drop. Not by much, just 1 to 2 degrees. But it has to happen, and your hypothalamus is in charge of making it happen. The hypothalamus is remarkable. It's only about the size of an almond, a tiny cluster of nuclei deep in the center of your brain, but it controls so much. Body temperature, hunger, thirst, fatigue, sleep, circadian rhythms, and some aspects of memory and emotion. For sleep, what matters most is its role as your body's thermostat. Your hypothalamus monitors your core temperature once every second. That's 86,400 times per day. And it's not just passively watching, it's actively adjusting. Constantly. When you're too hot, it triggers sweating, vasodilation in your skin to radiate heat. Behavioral changes like seeking shade. When you're too cold, it triggers shivering, vasoconstriction to preserve heat. Behavioral changes like seeking warmth. But for sleep, the adjustment is more subtle, more precise. As evening approaches, your hypothalamus begins a carefully timed temperature drop. Not a crash, not a sudden change. A gentle, gradual decrease of about 1 to 2 degrees Celsius over the course of a few hours. This temperature drop is essential. Without it, you cannot fall asleep. It's not optional. It's biological law. Research by Matthew Walker at UC Berkeley's Sleep Lab has shown that even a half-degree variation can affect sleep onset. Your body doesn't just prefer cooler temperatures for sleep, it requires them. Here's how your hypothalamus does it. As the evening progresses, as light levels drop, and your circadian system signals that sleep time is approaching, your hypothalamus opens blood vessels in your hands and feet. This is called peripheral vasodilation. Blood flow increases to your extremities. Warm blood from your core travels out to your hands and feet, where it can radiate heat away from your body. Your hands and feet act like heat exchangers. This is why your hands often feel warmer as you get drowsy. It's not your imagination, it's your brain actively dumping heat from your core to prepare you for sleep. At the same time, your metabolic rate decreases slightly. Your body produces less heat. The combination of increased heat radiation and decreased heat production creates that 1 to 2 degree drop your brain needs to initiate sleep. Kurt Kreutzsche, a researcher at the University of Basel, spent years studying this thermal transition. He found that the ratio between core temperature and skin temperature is one of the best predictors of sleep onset. When your core cools and your extremities warm, sleep comes naturally. When these temperatures stay mismatched, when your core stays too warm or your extremities stay too cool, sleep is delayed, sometimes for hours. This is why a cold room helps you sleep. Not because your brain likes the cold, but because it's easier for your hypothalamus to radiate heat when the ambient temperature is lower. You're working with your biology, not against it. Your hypothalamus is also connected to your circadian timing system. There's a tiny cluster of neurons called the suprachiasmatic nucleus, the SCN, sitting right in your hypothalamus. About 20,000 neurons. This is your master clock. The SCN tracks the 24-hour cycle of day and night, and it tells your hypothalamus when to begin the temperature drop, usually starting about 2 hours before your habitual bedtime. If you typically fall asleep at 11 p.m., your core temperature starts dropping around 9 p.m. Your body doesn't wait for you to decide it's bedtime. It begins the preparation automatically. This is why regular sleep schedules help. Your SCN learns the pattern. It anticipates. It prepares your body in advance. When you have an irregular schedule, your SCN gets confused. It doesn't know when to start the temperature drop. Sleep becomes harder. But when you're consistent, your brain becomes efficient. The temperature drop happens on schedule. By the time you lie down, your body is already primed for sleep. Right now, as you lie here, your hypothalamus is monitoring your temperature. It knows where you are in the circadian cycle. It knows whether you're on schedule or not. And it's making micro adjustments every single second to either facilitate sleep or keep you awake, depending on what your biology needs. There's something important to understand about the system. You cannot force it. You cannot consciously lower your core temperature by 1 to 2 degrees. Your conscious mind doesn't have that level of control, but you can support it. You can keep your bedroom cool. Most sleep scientists recommend 60 to 67 degrees Fahrenheit, about 15 to 19 degrees Celsius. This gives your hypothalamus the best conditions to radiate heat. You can avoid heavy meals close to bedtime. Digestion generates heat. If your body is busy digesting a large meal, your core temperature stays elevated. Your hypothalamus has to work against that heat production. You can take a warm bath or shower 1 to 2 hours before bed. This seems counterintuitive. Wouldn't warm water raise your temperature? Yes, initially. But when you step out of the bath, your body rapidly radiates that heat away. The rebound cooling can actually facilitate the temperature drop your brain needs. But beyond these supports, you have to let your hypothalamus do its job. You have to trust that it knows the timing, that it's been doing this every single night of your life, that it will continue doing it tonight. Your conscious worry about sleep doesn't help the temperature drop. It might actually interfere by activating your sympathetic nervous system, which generates heat and maintains alertness. The gift you can give your hypothalamus tonight is the same gift you gave your brainstem. Get out of the way. Let it work. Let your body sink into the surface beneath you. Your hypothalamus is already working. The temperature drop has begun or will begin soon. You don't need to monitor it. You don't need to feel it happening. Just know that deep in your brain, an almond-sized cluster of neurons is conducting a thermal symphony, opening blood vessels, adjusting metabolism, preparing every system in your body for the transition to sleep. It's been doing this job for you since you were born. It will do it tonight, and tomorrow night, and every night for the rest of your life. You are held by processes you can't see, can't feel, can't consciously control. And that's exactly as it should be. Your brain is managing what your conscious mind could never manage alone. The autonomic control system keeps you alive. The temperature regulation system prepares you for sleep. And there are 5 more systems still working for you right now. Let's continue this gentle journey. Sleep is not wasted time. It's not something you do because you're too tired to do anything else. Sleep is when your brain does some of its most important work. Work you can't do while you're awake. Work that requires your conscious mind to be offline. Work that repairs, restores, and prepares you for tomorrow. Right now, even before you fall asleep tonight, your brain is preparing for this work. And once you drift off, a whole cascade of restorative processes will begin. Let me tell you about one of the most important discoveries in sleep science in the last 20 years. In 2012, a neuroscientist named Maiken Nedergaard made a breakthrough. She discovered that your brain has a cleaning system, a waste removal system, and it only works during sleep. She called it the glymphatic system. During the day, while you're awake and active, your brain cells, your neurons, are tightly packed together. They're working hard, producing energy, sending signals, making connections. And in the process of all that work, they generate waste products, metabolic byproducts, toxic proteins that can damage cells if they accumulate. For years, scientists wondered how the brain cleared these toxins. Other organs in your body have the lymphatic system, a network of vessels that drain waste. But the brain doesn't have lymphatic vessels. So how does it clean itself? Dr. Nedergaard found the answer. And here's what's truly remarkable. Your brain cells don't just clean themselves. They shrink. Actually shrink by 60% every single night. Imagine your brain compressing itself like a sponge to let cleaning fluid flow through. During sleep, your brain cells shrink, not dramatically, but noticeably, by about 60%. And when they shrink, spaces open up between them, tiny channels. And through these channels, cerebrospinal fluid flows. This clear fluid that surrounds your brain and spinal cord, it washes through the spaces between your cells like a tide, carrying away the toxic proteins and waste products that accumulated during the day. This is the glymphatic system, and it's almost exclusively active during sleep. When you're awake, your brain cells are swollen, pressed together. There's no room for the cleaning fluid to flow. But when you sleep, when your cells shrink, the glymphatic system activates. Waste is flushed out. Your brain is restored. Studies have shown that one night of sleep deprivation can reduce this waste clearance by 40%. The toxins that should have been removed stay in your brain, and over time, the accumulation of these proteins has been linked to cognitive decline, neurodegenerative diseases, even Alzheimer's. Sleep isn't just rest, it's maintenance, essential, irreplaceable maintenance. Tonight, when you finally drift off, your glial cells, the support cells in your brain, will begin to shrink. The spaces between your neurons will widen, and cerebrospinal fluid will start its nightly cleansing cycle. You won't feel this happening. You won't be aware of it, but it will be happening nonetheless. By tomorrow morning, your brain will be 20 to 30% more efficient at forming memories, processing information, and making decisions, not because you rested, but because your brain was cleaned, restored, prepared. This is one of the reasons why sleep deprivation feels so awful. It's not just that you're tired, it's that your brain is trying to function while accumulating toxins that should have been removed. Your neurons are swimming in waste products, trying to fire signals through pollution. When you sleep well, you wake up clear, not just rested, clear, because your brain is literally cleaner. But the glymphatic system is just one part of what happens during sleep. There's so much more. Growth hormone is released during deep sleep. This hormone doesn't just help children grow. In adults, it repairs tissues, builds muscle, strengthens bones, and regenerates cells. Without adequate deep sleep, growth hormone secretion decreases. Your body's ability to repair itself is compromised. Your immune system consolidates during sleep. T cells, the white blood cells that fight infection, become more effective after a good night's sleep. Cytokines, proteins that help your immune system respond to threats, are produced and released. Think about this. While you lie here worrying about tomorrow's to-do list, your brain is running programs you didn't even know existed. Growth hormone release, immune consolidation, protein synthesis, all happening automatically, all happening for you. Research has shown that people who sleep less than 7 hours a night are almost 3 times more likely to develop a cold when exposed to the virus compared to those who sleep 8 hours or more. Sleep isn't just correlated with immune function, it's causal. Sleep strengthens your immune system. Sleep deprivation weakens it. Protein synthesis ramps up during sleep. Your brain needs to build new proteins to strengthen neural connections, to consolidate memories, to repair damaged cells. This synthesis happens primarily during sleep. It's a reminder that your body knows how to heal itself. During the day, your brain is too busy processing information, responding to stimuli, managing your body. It doesn't have the resources to focus on deep repair. But at night, when the demands decrease, when your conscious mind is offline, your brain can dedicate energy to restoration. Think about what this means. Every night of your life, your brain has been doing this work, shrinking cells to clean between them, releasing growth hormone to repair your body, strengthening your immune system, building the proteins you need for tomorrow. You didn't have to schedule this. You didn't have to remember to activate your glymphatic system or release growth hormone. Your brain did it automatically. It's been doing it since you were born, and it will do it again tonight. While you sleep, while your conscious mind is gone, while you're not thinking or worrying or trying to control anything, your brain will be working harder than you can imagine, performing complex biological processes that scientists are still trying to fully understand. This is why sleep is not optional. It's not something you can catch up on later. Not really. Every night you skip, every night you cut short, you're denying your brain the time it needs for essential maintenance. But tonight, you have the opportunity to give your brain what it needs, to lie here, to let go, to drift off, and to let these restorative processes unfold as they're meant to. If you're feeling guilty about sleeping, let this knowledge free you from that guilt. Sleep is not laziness. It's not wasted time. It's when your brain does work that cannot be done any other way. If you're lying here thinking you should be productive, that you should be working or studying or doing something useful, let me remind you of this. There is nothing more productive than sleep. Nothing that will make you healthier, smarter, more resilient, more capable tomorrow than the sleep you get tonight. The most productive thing you can do right now is close your eyes and trust your brain to do its work. The glymphatic system is waiting. The growth hormone is waiting. The immune consolidation is waiting. The protein synthesis is waiting. All of it is ready to begin the moment you let go. You don't need to understand the details. You don't need to know the molecular mechanisms or the neural pathways. Your brain understands, and it's been waiting all day for this moment. The moment when you finally give it permission to shift from activity to restoration, from consciousness to repair. So, let your shoulders relax. Let your jaw unclench. Let your body sink deeper into rest. Your autonomic control system is managing your heartbeat and breathing. Your temperature regulation system is preparing your body for sleep. And your repair and restoration system is ready to begin its nightly work. 3 systems down. 4 more to go. But already, you can feel it, can't you? The pattern, the competence, the tireless work your brain has been doing for you every moment of your life. You don't have to be in charge. You were never meant to be in charge of these processes. Your brain is in charge, and it's doing a remarkable job. Let's continue. Every experience you had today is stored somewhere in your brain. Every conversation, every sight, every sound, every thought, every sensation. But right now, those memories are temporary, fragile. Stored in a part of your brain called the hippocampus, a seahorse-shaped structure deep in your temporal lobe. The hippocampus is like a temporary holding area. It can't store memories forever. It doesn't have the capacity. So every night during sleep, your brain makes a decision. Which memories should be kept? Which should be strengthened? Which should be discarded? And then it does something remarkable. It replays those memories over and over at incredible speed, transferring them from temporary storage to permanent storage. From your hippocampus to your cortex. This is memory consolidation, and it happens while you sleep. During deep sleep, your hippocampus becomes incredibly active, even though you're unconscious, even though you're not thinking or experiencing anything new. Your hippocampus is replaying the day's experiences, not at normal speed, much faster, between 5 and 20 times faster than real time. A conversation that took 5 minutes during the day might be replayed in your hippocampus in 15 seconds. An experience that lasted an hour might be compressed into 3 minutes. This rapid replay isn't random. Your brain is reinforcing the neural pathways associated with those memories. Every time a memory is replayed, the connections between neurons strengthen. The memory becomes more stable, more permanent. György Busaki, a neuroscientist at NYU, has spent decades studying this process. He calls it hippocampal replay, and he's found that it's essential for learning. Without sleep, without this replay, memories don't consolidate. They fade. You can study for hours during the day, but if you don't sleep that night, much of what you learned will be lost. Sleep doesn't just rest your brain. Sleep is when your brain actually integrates what you learned. But it's not just about strengthening memories. It's also about making connections between them. During REM sleep, rapid eye movement sleep, your brain doesn't just replay individual memories. It combines them, finds patterns, makes associations. This is why problems often seem easier after sleep. Why solutions appear in the morning that weren't visible the night before. Your brain has been working on those problems while you slept, making connections you couldn't consciously make. There's a reason why we say, sleep on it. It's not just folk wisdom, it's neuroscience. Your brain is smarter when it's offline, more creative, more capable of finding solutions. Because when your conscious mind is quiet, your brain can process information in ways that aren't possible during waking consciousness. There's another phenomenon that happens during sleep. Your brain also prunes connections. All day, as you learn and experience things, your brain forms new connections. Synapses, the junctions between neurons. Some of these connections are important. Some are trivial. If your brain kept every connection it formed, it would quickly become overwhelmed, cluttered, inefficient. You'd remember everything, which means you'd effectively remember nothing. The important would be lost among the unimportant. During sleep, your brain prunes. It weakens the synapses that aren't important, and it strengthens the ones that are. It's like clearing today's clutter to make room for tomorrow. Chiara Sorelli and Giulio Tononi, researchers at the University of Wisconsin, proposed this theory in 2003, and subsequent research has supported it. During sleep, particularly deep sleep, synapses are pruned back to baseline. Your brain is reset, prepared to learn again tomorrow. Without this pruning, learning would be impossible. Your brain would be saturated, no room for new information. Sleep is what creates the space for tomorrow's learning. By clearing out today's clutter, by deciding what to keep and what to discard, think about what your brain will do tonight. It will replay today's experiences at high speed, deciding which are worth keeping, which memories should become permanent. It will strengthen those neural pathways, making the important memories stable. It will find connections between ideas, patterns you didn't see consciously, solutions to problems you've been struggling with. While you sleep, your brain will be solving puzzles you couldn't solve awake, and it will prune away the unnecessary connections, the trivial details, the clutter, making room for tomorrow. You don't have to do any of this consciously. You can't. This work happens in the darkness of sleep, beyond your awareness, beyond your control. But it happens. It's happening every night. It's been happening your entire life. If you're a student, this is why cramming doesn't work. You can pour information into your brain all night before an exam, but without sleep, that information won't consolidate. It won't transfer from temporary to permanent storage. By the time you take the test, it's already fading. But if you study, then sleep, then review, your brain has time to do its work. The information becomes integrated, stable, accessible when you need it. If you're trying to learn a new skill, a musical instrument, a language, a sport, sleep is when that learning solidifies. Your brain replays the movements, the sounds, the patterns. Each replay strengthens the neural pathways. By morning, the skill that felt awkward yesterday feels more natural. This is why babies sleep so much. They're learning constantly, forming millions of new connections every day. And they need massive amounts of sleep to consolidate all that learning, to build the neural structures that will serve them for a lifetime. As adults, we don't sleep as much as babies, but the process is the same. Every night, your brain consolidates, integrates, prunes, prepares. Tonight, your hippocampus will replay today. Your cortex will receive those replayed memories and make them permanent. Your synapses will be pruned and strengthened. And tomorrow morning, you'll wake up with a brain that's been reorganized, optimized, prepared to learn again. You don't need to worry about whether this will happen. You don't need to try to make it happen. Your brain has been doing this every night since you were born. It knows how. It knows when. It knows what to keep and what to discard. Your job right now is simply to allow it, to let go of the day, to stop trying to hold on to every thought, to trust that your brain will save what matters and release what doesn't. The memories worth keeping will be kept. The connections worth making will be made. The space worth creating will be created. All of it will happen while you sleep, automatically, perfectly, without any conscious effort from you. 4 systems down, 3 more to go. Your autonomic control system manages your vital functions. Your temperature regulation system prepares your body for sleep. Your repair and restoration system cleans and heals your brain. And your memory consolidation system integrates everything you learned today. All of this is happening right now, working together, working for you. You are held by processes you can't see, guided by systems you can't control. And that's not a weakness. It's your brain's greatest strength. The next system we'll explore is one that might surprise you. It's about emotions, about the work your brain does to process the feelings you experienced today, to heal the hurts, to integrate the joys, to prepare your emotional landscape for tomorrow. Your brain is an emotional processing machine, and it's most active during REM sleep. Let's continue this gentle journey together. Whatever happened today that created stress, fear, sadness, anger, or overwhelm, your brain registered it. Every emotional moment was recorded. Every difficult conversation, every worry, every hurt. And tonight, while you sleep, your brain is going to do something remarkable with those emotions. It's going to process them, strip away some of their intensity, help you integrate them, heal them, not by forgetting, not by suppressing, but by recontextualizing, by separating the memory from its full emotional charge. This happens during REM sleep, and it's one of the most therapeutic things your brain does. REM sleep is the stage where most dreaming occurs. Your eyes move rapidly beneath your closed lids. Your brain becomes almost as active as it is when you're awake, but your body is paralyzed. You can't move, except for your breathing and eye movements. This paralysis is protective. It keeps you from acting out your dreams. But it's also part of what makes REM sleep so therapeutic. During REM, your brain replays emotional memories, just like it replays factual memories during deep sleep. But something different happens during REM. The emotional memories are replayed without the stress hormone norepinephrine. Normally, when you experience something emotionally charged, norepinephrine floods your brain. This is part of your stress response. It amplifies the emotional impact. It makes the memory vivid, strong, sometimes overwhelming. But during REM sleep, norepinephrine levels drop to nearly zero. Your brain shuts off this stress chemical. So when your amygdala, the emotional center of your brain, replays today's difficult moments during REM, it's replaying them without the full chemical cocktail that made them so intense. The memory is there, the content is there, but the emotional sting is reduced. Matthew Walker, the sleep researcher at UC Berkeley, describes this as overnight therapy. Your brain is giving you exposure therapy while you sleep. In exposure therapy, a person confronts a traumatic memory repeatedly in a safe environment until the memory loses its power to trigger intense fear or anxiety. The memory remains, but the emotional reaction diminishes. REM sleep does this naturally. Every night, you re-experience today's emotional moments during dreams. But because norepinephrine is absent, those moments don't have the same emotional punch. Your brain is learning this memory doesn't need such a strong emotional tag. It's safe to remember this without so much pain. Over multiple nights, over multiple REM cycles, difficult memories become easier to bear. The content remains accessible. You still remember what happened, but it doesn't hurt as much. It doesn't trigger the same physical stress response. This is why people say things look better in the morning, why emotions feel less intense after sleep. It's not just that time has passed. Your brain has been actively working to reduce the emotional charge. The amygdala is central to this process. This almond-shaped structure deep in your brain is your emotional processor. It tags memories with emotional significance. It triggers fear responses. It connects experiences with feelings. During the day, your amygdala can become overactive, especially if you're stressed, anxious, or dealing with difficult situations. It sees threats everywhere. It amplifies emotions. But during REM sleep, your prefrontal cortex, the rational, executive part of your brain, comes back online. Not fully, not like it is when you're awake, but enough to modulate the amygdala. The prefrontal cortex provides context. It says, yes, this was difficult, but here's the bigger picture. Here's why it's not as threatening as it feels. Here's how it fits into your life story. This collaboration between the amygdala and prefrontal cortex during REM is what allows emotional reprocessing. The amygdala brings the emotion. The prefrontal cortex provides perspective. Together, they integrate the experience. By morning, the memory has been woven into your broader emotional narrative. It's no longer a raw wound. It's becoming a scar. Still visible, still part of you, but healed. Rosalind Cartwright, a dream researcher, spent decades studying this phenomenon. She found that people who are going through difficult life transitions, divorces, losses, traumas, who remember their dreams and have emotionally rich dream content, tend to have better emotional outcomes, not because the dreams themselves are pleasant. Often they're not, but because those dreams are evidence of active emotional processing. The brain is working, it's integrating, it's healing. People who suppress their dreams, who don't get enough REM sleep, who wake up frequently during REM cycles, they struggle more. The emotions don't process, they accumulate, they intensify. This is one of the reasons sleep deprivation is so harmful to mental health. Without REM sleep, emotions don't get processed. Yesterday's stress adds to today's stress, adds to tomorrow's stress. The emotional burden becomes unbearable. But with healthy REM sleep, each night provides a reset, not a complete reset. You don't forget, but a recalibration. The volume gets turned down, the intensity decreases. You gain perspective. There's a phrase, sleep on it. You've probably heard it, probably used it. When facing an emotional decision or a difficult situation, someone advises, don't react now. Sleep on it. See how you feel in the morning. This isn't just folk wisdom, it's neuroscience. Your brain needs time to process, and that processing happens during sleep, particularly during REM. By morning, the situation hasn't changed, but your emotional response to it has been modulated. You can think more clearly, react more appropriately. This is why it's dangerous to make important decisions when you're sleep deprived. Your emotional regulation is compromised. Your amygdala is overactive. Your prefrontal cortex isn't providing adequate modulation. You're more likely to react impulsively, more likely to be overwhelmed by emotions that, after sleep, would feel manageable. Sleep isn't just physical rest, it's emotional regulation. It's mental health maintenance. It's psychological healing. Tonight, when you enter REM sleep, and you will, your brain will begin its emotional work. It will replay moments from today, conversations that were difficult, situations that created stress, worries that felt overwhelming, and it will replay them without the full norepinephrine response. It will give you exposure in a safe space. It will help you integrate. Your amygdala and prefrontal cortex will collaborate. Emotion and reason, feeling and perspective. Together, they'll weave today's experiences into your emotional narrative. And by tomorrow morning, while the memories remain, the emotional intensity will have decreased, not eliminated. That's not the goal, but modulated, made bearable, made manageable. You don't need to control this process. You can't. It happens in REM sleep, when your conscious mind is offline, when you're dreaming, when you're not trying. Your job is simply to allow it, to get enough sleep, to give your brain enough REM cycles, to trust that your brain knows how to heal emotional wounds just as it knows how to heal physical wounds. If you're lying here carrying pain from today, from yesterday, from years ago, know this. Your brain wants to help you process it. It's designed to help you process it. But it needs time. It needs sleep. It needs REM. Every night you sleep well is a night of emotional healing. Every REM cycle is a therapy session. Every dream, even the difficult ones, is your brain working to help you integrate and move forward. You don't need to understand the neurochemistry. You don't need to analyze your dreams. Your brain is doing the work, whether you're aware of it or not. Just sleep. Just allow the process. Just trust that your brain has been healing emotional wounds for as long as humans have existed. And it will heal yours too. 5 systems down, 2 more to go. Your brain is extraordinary. It manages your heartbeat and breathing. It regulates your temperature. It repairs and restores itself. It consolidates your memories. It processes your emotions. All of this happens automatically. All of this happens whether you're aware of it or not. All of this happens because your brain is far more competent than you consciously realize. The next system connects you to something larger than yourself, to the planet, to the rhythm of day and night, to the 24-hour cycle that has governed life on Earth for billions of years. Your circadian timing system, your biological clock. Let's explore it together. Deep in your hypothalamus, in that same almond-sized structure we talked about earlier, there's a cluster of about 20,000 neurons. Just 20,000 out of the 86 billion neurons in your entire brain. But these 20,000 neurons have a special job. They keep time. Not the time on your clock, not hours and minutes, but biological time, the rhythm of day and night, the 24-hour cycle. This cluster is called the suprachiasmatic nucleus, the SCN, and it's your master clock. The SCN is remarkable. Even if you removed it from your brain and kept it alive in a dish, it would continue to keep time. It would continue its 24-hour rhythm. These neurons have an intrinsic ability to cycle, to oscillate, to count the passage of day and night. But in your brain, connected to your eyes, connected to the rest of your body, the SCN does so much more than just keep time. It orchestrates your entire physiology around the 24-hour cycle. It tells your hypothalamus when to drop your body temperature for sleep. It tells your pineal gland when to release melatonin. It tells your liver when to process glucose. It tells your cardiovascular system when to adjust blood pressure. It coordinates thousands of processes across your entire body to align with the day-night cycle. You are not just living through time. You are synchronized with the planet's rotation. Your biology is entrained to Earth's 24-hour spin. How does your SCN know what time it is? How does it know when it's day and when it's night? Through light. You have specialized cells in your retina, in the back of your eye, called intrinsically photosensitive retinal ganglion cells. These cells don't help you see images. They don't contribute to visual perception. They do only one thing. They detect light levels. When light hits these cells, they send signals directly to your SCN. Bright light, especially blue light, tells your SCN that it's daytime. Darkness tells your SCN that it's nighttime. This is how your internal clock stays synchronized with the external world. Every morning, when light enters your eyes, your SCN resets. It says, okay, it's day. Let's begin the daytime programs. Alert the body, suppress melatonin, raise body temperature, increase cortisol, prepare for activity. Every evening, when light levels drop, your SCN says, okay, it's night. Let's begin the nighttime programs. Release melatonin, drop body temperature, reduce cortisol, prepare for sleep. Melatonin is often called the sleep hormone, but that's not quite accurate. Melatonin doesn't make you sleep. It signals to your body that it's nighttime. It's a messenger, a herald of darkness. Your pineal gland, a tiny pine cone-shaped gland deep in your brain, produces melatonin. But it doesn't produce it all day. Only at night. Only when your SCN tells it to. As evening approaches, as your SCN detects decreasing light levels, it sends signals to your pineal gland. And your pineal gland begins to secrete melatonin into your bloodstream. Melatonin levels start rising about 2 hours before your habitual bedtime. This is called dim light melatonin onset. It's your biological signal that sleep is approaching. Melatonin makes you feel drowsy. It lowers your alertness. But more importantly, it signals to every cell in your body that it's nighttime. Time to shift into nighttime mode. Throughout the night, melatonin levels remain elevated. And then, in the early morning, as light levels begin to increase, your SCN tells your pineal gland to stop. Melatonin production shuts off. Within about an hour, your melatonin levels drop back to daytime baseline, and you wake up. This is why light exposure matters so much for sleep. Bright light in the evening, especially blue light from screens, confuses your SCN. It thinks it's still daytime. It delays melatonin release. Your biological clock gets pushed later. You might stay up later than you intend, not because you're not tired, but because your biology hasn't received the signal that it's nighttime. And then, in the morning, if you wake up in a dark room, if you don't get bright light exposure early, your SCN doesn't get the reset signal. Your clock drifts later and later. You become a night owl, not by choice, but by biology. This is called circadian misalignment. Your internal clock is out of sync with the external world. You're trying to sleep when your biology thinks it should be awake. You're trying to be alert when your biology thinks it should be asleep. And it's exhausting, confusing. It creates insomnia, fatigue, mood problems, metabolic issues, all because your 20,000 SCN neurons can't get clear signals about what time it is. But when your circadian rhythm is aligned, when your SCN is synchronized with the actual day-night cycle, everything works better. You feel sleepy at night because your biology is preparing for sleep. You wake up in the morning because your biology is preparing for activity. You have energy during the day because your systems are optimized for daytime function. Every sunset you've ever watched, every sunrise you've ever greeted, every time you felt sleepy as darkness falls, that's not coincidence. That's your SCN. Those 20,000 neurons connecting you to billions of years of planetary rhythm. You are Earth's rotation expressed in human form. It's a reminder that you're connected to something larger than yourself. This isn't just about sleep. Your entire physiology follows circadian rhythms. Your metabolism, your immune function, your cardiovascular system, your hormone production, your cognitive performance. There's a best time for your body to process glucose, a best time for your immune system to fight infection, a best time for your cardiovascular system to handle stress. And your SCN coordinates all of this. In 2017, 3 scientists, Jeffrey Hall, Michael Rosbash, and Michael Young, won the Nobel Prize in Physiology or Medicine for their work on circadian rhythms. They discovered the molecular mechanisms, the clock genes, that create these 24-hour cycles. And what they found was profound. Every cell in your body has its own clock, not just your SCN. Every single cell has clock genes that create a 24-hour rhythm, but the SCN is the master. It keeps all those cellular clocks synchronized. It's the conductor of a symphony, where every cell is an instrument, and they all need to play together. Right now, your SCN is keeping time. Those 20,000 neurons are firing in their 24-hour pattern. They know where you are in the day-night cycle. They know what your body should be doing right now. And because it's evening, because you're lying here preparing for sleep, your SCN has signaled your pineal gland. Melatonin is being released. Your body temperature is dropping. Your systems are shifting into nighttime mode. This is happening automatically. You don't have to tell your SCN what time it is. It knows. You don't have to tell your pineal gland to release melatonin. Your SCN is telling it for you. Your biology is synchronized with the planet. You are connected to Earth's rotation. When you feel sleepy at night, it's not just because you're tired. It's because your body is responding to billions of years of evolution, to the fact that Earth has always rotated, to the fact that light and dark have always alternated. Your circadian rhythm is planetary timing expressed through your biology. If you've been struggling with sleep, if your schedule has been irregular, if you've been getting bright light at night and staying in darkness in the morning, your SCN is confused. It doesn't know when to signal sleep and when to signal wakefulness. But the beautiful thing is, your SCN can be retrained. It can resynchronize. If you get bright light exposure in the morning, especially sunlight, within the first hour of waking, your SCN gets a strong reset signal. It says this is morning. This is when the day begins. If you dim the lights in the evening, if you avoid bright screens before bed, if you create a consistent routine, your SCN learns the pattern. It begins to anticipate. It starts preparing your body for sleep before you even lie down. Consistency is key. Not perfection, but consistency. Your SCN thrives on predictability. When you go to bed at roughly the same time, when you wake up at roughly the same time, your biology can optimize around that schedule. And when your circadian rhythm is synchronized, sleep comes naturally. You feel sleepy when you should. You wake up when you should. Your body is working with you, not against you. Let your body sink deeper into rest. Your SCN is keeping time. It knows it's night. It's already begun the processes that will lead to sleep. Your autonomic system is running. Your temperature is dropping. Your repair systems are ready. Your memory consolidation is prepared. Your emotional processing is waiting. And your circadian clock is ticking, counting down to the moment when all these systems converge and you finally let go into sleep. 6 systems down. 1 more to go. And this last system is perhaps the most mysterious, the most subtle. The consciousness transition system. The system that guides you from wakefulness through the stages of sleep into deep unconsciousness and back again. Your brain knows how to turn itself off, and it knows how to turn itself back on. Let's explore this final system together. You cannot force yourself to fall asleep. The harder you try, the more alert you become. It's a paradox. Sleep requires letting go, but letting go requires trust, and trust requires understanding. So let me tell you how your brain transitions from wakefulness to sleep. What happens in those mysterious moments when consciousness fades and you drift away? Because when you understand the process, when you see that your brain knows exactly what it's doing, it becomes easier to trust, easier to let go, easier to allow the transition that your brain has been orchestrating every night of your life. Sleep is not an on-off switch. It's a gradual transition through distinct stages. Your brain doesn't just turn off. It shifts down, level by level, from wakefulness to light sleep to deep sleep to REM sleep and back again. All night long, your brain cycles through these stages in roughly 90-minute intervals. This architecture was discovered in 1968 by Alan Rechtschaffen and Anthony Cales. They created the first manual for sleep staging. And while the terminology has been updated, the basic structure remains. Sleep has architecture, stages, a predictable progression. Understanding this architecture helps, because when you're lying here trying to fall asleep, It helps to know that there's a process, that your brain is walking through steps, that you're not broken if sleep doesn't come instantly. The first gatekeeper of sleep is your thalamus. This egg-shaped structure deep in the center of your brain is your sensory relay station. Every sight, sound, touch, smell, almost every sensation from your body passes through your thalamus before reaching your conscious awareness. During wakefulness, your thalamus is wide open. Signals flow freely. You're aware of everything: the pressure of the surface beneath you, the sounds in your environment, the temperature of the air. Your thalamus is letting it all through. But as you begin to relax, as your brain starts the transition towards sleep, your thalamus begins to close its gates. Gradually, selectively, it starts filtering out less important sensations. The hum of a fan becomes less noticeable. The pressure of your pillow fades into background. Your awareness narrows. This is called thalamic gating, and it's one of the first steps in the transition to sleep. You're still conscious, you're still aware, but the volume of sensory input is decreasing. Your brain is creating a buffer between you and the external world, protecting your consciousness so it can begin to disengage. The second player in sleep onset is your reticular activating system, the RAS. This network of neurons in your brainstem controls arousal, wakefulness, alertness. When your RAS is highly active, you're wide awake, alert, engaged with the world. When your RAS activity decreases, you become drowsy, less alert, more likely to drift. As you lie here, relaxing, not moving, breathing steadily, your RAS is receiving fewer and fewer arousal signals. There's no danger, no need for vigilance, no reason to stay alert. So the RAS gradually reduces its output. You feel this as drowsiness, as your eyelids becoming heavy, as your thoughts beginning to wander, as your body feeling heavier, sinking, relaxing. This is your RAS downshifting, letting go of wakefulness, allowing the transition to begin. When these two systems, thalamic gating and RAS downregulation, reach a certain threshold, you enter stage 1 sleep, N1 in the modern terminology. This is the lightest stage, the transition stage. You're not quite awake, not quite asleep. Your brain waves change. During wakefulness, your brain produces beta waves, fast, irregular. When you relax with your eyes closed, alpha waves appear, slower, more rhythmic. And as you drift into N1, alpha waves give way to theta waves, even slower. This is the hallmark of stage 1. Stage 1 usually lasts only a few minutes. It's a bridge. Your conscious awareness is fading but not gone. You might still hear sounds, still have some awareness of your environment, but it's distant, dreamlike, not fully engaged. Some people experience hypnic jerks during stage 1, that sudden sensation of falling, accompanied by a muscle twitch that jolts you back to awareness. This is normal. It happens when your muscles relax rapidly and your brain misinterprets the relaxation as falling. A final check before letting go completely. If you stay relaxed, if you don't fight the process, you transition from stage 1 to stage 2. N2. This is where you spend about 50% of your total sleep time. This is light sleep, but it's real sleep. You're no longer conscious. You wouldn't respond to your name being called softly. You've crossed the threshold. You've probably experienced this yourself. That moment when you can't quite tell if you're awake or asleep. That floating sensation. That's stage 1. Your brain beginning its nightly journey through these stages, and it knows the way. It always has. Stage 2 is characterized by 2 distinct brainwave patterns, sleep spindles and K complexes. Sleep spindles are sudden bursts of brain activity. They look like little tornadoes on an EEG. These spindles are thought to be involved in memory consolidation. They're your brain beginning the work of integrating today's experiences. Each spindle is your brain strengthening a neural connection, consolidating a memory. K-complexes are large, slow waves. They're thought to be your brain's way of suppressing external stimuli, keeping you asleep despite sounds or minor disturbances. Your brain is protecting your sleep, filtering out the world. During stage 2, your heart rate slows, your body temperature drops further, your muscles relax more completely, you're settling deeper into sleep. Your brain is preparing for the next stage. Stage 3 is deep sleep, slow wave sleep. N3. This is where the magic happens. This is where your brain does its most intensive repair work. Your brain waves change dramatically. Delta waves appear. These are the slowest, largest waves your brain produces. Deep, rolling oscillations. They look like ocean waves on an EEG. Slow, powerful, hypnotic. During stage 3, you are deeply unconscious. It would take significant stimulation to wake you. A loud noise, someone shaking you. Your brain has shut down sensory processing almost completely. You are unreachable, gone. Have you ever woken from deep sleep feeling disoriented, not knowing where you are? That's stage 3. You were so far down in delta waves, so removed from consciousness, that your brain needs a moment to reorient. This is when your glymphatic system is most active, when your brain cells shrink and cerebrospinal fluid flushes through, when growth hormone is released, when your immune system strengthens. This is restorative sleep, essential sleep. You need to reach stage 3. You need these delta waves. Without deep sleep, you don't get the full restorative benefits. You wake up feeling unrefreshed, foggy, unwell. But when you get adequate stage 3, when you spend enough time in these slow delta waves, your body and brain are restored, repaired, prepared for tomorrow. About 90 minutes after you first fall asleep, something remarkable happens. You enter REM sleep, rapid eye movement sleep. Your brain becomes active again, almost as active as wakefulness. But you're not awake, you're dreaming. Your eyes move rapidly beneath your closed lids, tracking the images in your dreams. Your heart rate and breathing become irregular. Your brain waves look similar to waking beta waves. But your body is paralyzed. Except for your breathing and eye movements, you cannot move. This is when most vivid dreaming occurs, when your emotional processing happens, when your hippocampus replays memories and your cortex integrates them, when your brain makes creative connections, when problems are solved. REM sleep is essential, just as essential as deep sleep, but for different reasons. Deep sleep is for physical restoration. REM is for psychological integration. After REM, you cycle back, usually to stage 2, then maybe back to stage 3, then REM again. All night long, your brain cycles, 90 minutes per cycle, give or take, 4 to 6 cycles per night. With each cycle, deep sleep becomes shorter and REM becomes longer. Early in the night, you get more deep sleep. Later in the night, you get more REM. Your brain knows what it needs and when. This is the architecture of sleep. These are the stages your brain moves through, automatically, without your input, without your control. You can't force stage 3. You can't decide to have REM. Your brain orchestrates this. It knows the timing. It knows the sequence. It knows what you need. Your job is simply to allow it, to create the conditions, to lie still, to relax, to remove stimulation, to trust that your brain will do the rest. When you lie here trying to fall asleep, When you're frustrated that sleep won't come, remember this. Your brain is walking through a process: thalamic gating, RAS downregulation, alpha to theta waves, stage 1 to stage 2 to stage 3 to REM. It's not instant. It's not a switch. It's a gradual transition, and your brain knows how to make that transition. It's been making it every night of your life, so let go of the effort. Stop trying to fall asleep. You can't try your way into sleep. Sleep is what happens when you stop trying. Your thalamus will close its gates when it's ready. Your RAS will downregulate when conditions are right. Your brain waves will slow from beta to alpha to theta to delta. The stages will unfold. All of it will happen automatically, perfectly, just as it's been happening since you were born. Your consciousness will fade, not all at once, gradually, like a dimmer switch slowly turning down. You might not even notice the exact moment you cross from wakefulness to sleep. Most people don't. It's a blur, a fade, a gentle disappearance. And then, hours later, your brain will reverse the process. It will cycle back from REM to light sleep to wakefulness. Your thalamus will open its gates. Your RAS will ramp up activity. Your brain waves will speed up, and you'll wake, restored, repaired, ready, all 7 systems working together. Autonomic control keeping you alive, temperature regulation preparing your body, repair and restoration cleaning and healing, memory consolidation integrating what you learned, emotional processing healing what you felt, circadian timing synchronizing you with the planet, and consciousness transition guiding you through the stages of sleep. You don't control these systems. You were never meant to. Your brain controls them, and it does a remarkable job. Let your whole body relax now. Let every muscle soften. Let your breathing slow. Let your thoughts drift. Your brain has everything under control. It always has. 7 control systems, all working right now, all working for you. Let's take a moment to appreciate what we've explored together tonight. Your autonomic control system. Your brainstem sending 120,000 signals per second to your heart. Your pons orchestrating every breath. Your vagus nerve maintaining communication between your brain and body. Your parasympathetic system trying to shift you into rest and digest mode. All of this happening without your awareness, without your effort. Your brainstem managing the fundamentals of life so your conscious mind doesn't have to. Your temperature regulation system. Your hypothalamus monitoring your core temperature, 86,400 times per day. Opening blood vessels in your hands and feet to radiate heat. Coordinating with your circadian clock to time the temperature drop perfectly. Creating the thermal conditions necessary for sleep onset. All of this happening automatically. Your hypothalamus knowing exactly when to begin the cooling process. Your body preparing for sleep before you even realize you're tired. Your repair and restoration system. Your glymphatic system ready to activate the moment you sleep. Your brain cells prepared to shrink by 60%, creating space for cerebrospinal fluid to flush through. Growth hormone waiting to be released. Your immune system ready to consolidate. Protein synthesis ready to ramp up. All of this waiting for sleep. Waiting for the moment when your conscious mind goes offline and your brain can dedicate full resources to restoration, to cleaning, to healing, to preparing you for tomorrow. Your memory consolidation system. Your hippocampus ready to replay today's experiences at high speed. Your cortex ready to receive those memories and make them permanent. Sleep spindles ready to fire. Synaptic connections ready to strengthen or prune. All of this designed to help you learn, to help you integrate, to help you make sense of today and prepare for tomorrow. Your brain working overnight to optimize your neural networks. Your emotional processing system. Your amygdala ready to replay today's emotional moments during REM sleep. Your prefrontal cortex ready to provide context and perspective. Norepinephrine levels ready to drop, allowing you to reprocess difficult experiences without the full emotional charge. All of this designed to heal, to help you integrate difficult emotions, to strip away some of the intensity so memories remain accessible but bearable. Your brain providing overnight therapy without any conscious effort from you. Your circadian timing system. Your SCN keeping its 24-hour rhythm. Your pineal gland releasing melatonin as darkness signals nighttime. Every cell in your body following its clock genes, synchronized by your master clock. Your biology connected to Earth's rotation. All of this linking you to something larger than yourself, to planetary timing, to the rhythm that has governed life on Earth for billions of years. Your brain keeping you synchronized with the cosmos. Your consciousness transition system. Your thalamus closing its gates. Your RAS downregulating. Your brain waves slowing from beta to alpha to theta to delta. Your sleep stages unfolding in their 90-minute cycles. Stage 1 to stage 2 to stage 3 to REM and back again. All of this guiding you through the landscape of sleep. Your brain knowing the path, knowing the stages, knowing how to turn consciousness down and then, in the morning, how to turn it back up. 7 systems, billions of neurons, trillions of connections, countless chemical reactions, all working in perfect coordination, all working for one purpose, to keep you alive, to keep you healthy, to keep you functioning. You didn't design these systems. You didn't build them. You didn't even know they existed until tonight. But they've been working for you every moment of your life, since before you were born, since before you had conscious thought. Your brain is far more competent than you consciously realize, far more capable, far more trustworthy. And here's the most important thing to understand. These systems don't need your conscious attention. They don't need your monitoring. They don't need your control. In fact, your conscious attention often interferes. When you focus on your breathing, it becomes manual. When you try to control your heart rate, you create anxiety. When you try to force sleep, you prevent it. The gift you can give yourself tonight and every night is this. Get out of the way. Let your brain do what it does best. Trust that your autonomic control will keep you alive. Trust that your temperature regulation will prepare you for sleep. Trust that your repair systems will restore you. Trust that your memory systems will integrate your experiences. Trust that your emotional systems will process your feelings. Trust that your circadian clock will keep you synchronized. Trust that your consciousness will transition when it's ready. You are held by systems you cannot see, guided by processes you cannot control. And that's not a weakness. That's your greatest strength. Your brain has been doing this work for millions of years of evolution, across countless generations, across hundreds of thousands of human lifetimes. It knows what it's doing. You can trust it. If you're still awake, that's okay. Your brain is still preparing. The processes are still unfolding. Sleep will come when your systems align, when your thalamus finishes closing its gates, when your RAS completes its downregulation, when your temperature reaches the right threshold, when your circadian clock signals that it's time. You can't rush this, but you can allow it by lying still, by breathing gently, by letting your thoughts drift, by trusting your brain. If you've already drifted off, if you're no longer consciously hearing these words, that's perfect. That means your brain has done its job. Your consciousness has transitioned. Your systems are now running the overnight programs: repair, consolidation, processing, restoration. Either way, awake or asleep, your brain is working. Your 7 control systems are active. Everything is exactly as it should be. You are held, not by effort, not by willpower, not by conscious control, but by biology, by neuroscience, by billions of years of evolution, by processes so sophisticated that science is still discovering how they work. You are held by your brain, and your brain has never let you down. Not once, not ever. It kept you alive through infancy when you had no conscious awareness. It kept you alive through childhood when you were reckless. It keeps you alive now, even when you're anxious, even when you're overwhelmed, even when you feel like you're falling apart. Your brain is always working, always protecting, always trying to heal and restore and prepare you for tomorrow. You can trust it. You can let go. You can rest. If you're still with me, if you're still awake, thank you. Thank you for staying with me through this gentle journey into your brain. Thank you for trusting me with your bedtime. Thank you for allowing me to share these wonders with you. But more importantly, thank you to your brain. That 3-pound organ inside your skull that has been managing everything, controlling everything, protecting everything, without any conscious direction from you. Thank your medulla for every heartbeat. Thank your pons for every breath. Thank your hypothalamus for every temperature adjustment. Thank your glymphatic system for cleaning while you sleep. Thank your hippocampus for consolidating your memories. Thank your amygdala for processing your emotions. Thank your SCN for keeping you synchronized with the planet. Thank your thalamus and RAS for guiding you into sleep. These systems deserve your gratitude. And more than that, they deserve your trust. Sleep is not something you do. Sleep is something you allow. It's a surrender, a letting go, a trust fall into your brain's competence. You've spent your whole life trying to control things, trying to manage things, trying to stay on top of everything. And that's exhausting. That's why you're here. That's why sleep won't come easily. But tonight, you've learned something profound. You don't have to control everything. Your brain is already controlling what matters most. Your heart, your breathing, your temperature, your repair, your memories, your emotions, your timing, your consciousness. All of it is handled. All of it is managed. All of it is controlled. Not by you, by your brain, by systems that are far more competent than your conscious mind could ever be. So let go. Stop trying. Stop monitoring. Stop worrying. Your brain has this. It always has. It always will. Tonight, while you sleep, your brain will continue its work. The 7 systems we explored will run their programs. By morning, you'll be restored, repaired, integrated, healed, prepared. You won't remember most of what happened. You won't be aware of the glymphatic flush or the hippocampal replay or the emotional reprocessing. But it will have happened. Your brain will have done its work, and you'll wake up better for it. This happens every night, whether you think about it or not, whether you trust it or not. Your brain does its job, but it's easier when you trust. It's easier when you understand. It's easier when you can lie here and think, I don't have to figure this out. My brain knows what to do. If you found this video helpful, if this journey into your brain brought you peace, you're welcome to return tomorrow night. You're welcome to listen again. You're welcome to make this part of your bedtime routine. Your brain will be here, doing this work, whether you listen or not. but sometimes it helps to be reminded, to understand, to trust. I'll be here if you need that reminder. One sleepy soul at a time. Now, let everything go. Let your body sink completely. Let your breathing slow to its natural rhythm. Let your thoughts dissolve like mist in the morning sun. Your brain is in control. Your 7 systems are running. Everything is exactly as it should be. You are safe. You are held. You are cared for by the most sophisticated biological system in the known universe. Sleep well, dream deeply, trust your brain, and know that while you sleep, while your conscious mind is gone, your brain will be working tirelessly, perfectly, protecting you, restoring you, preparing you for tomorrow. Good night. Sleep well and sweet dreams.